Hello everyone, welcome to my channel. Let us derive an expression for a particle inside one-dimensional potential well or one-dimensional infinite square well. So now let us consider a potential well having a width is x is equal to a and the height of the well is infinite. A particle in this potential well is free to move except at two ends at x is equal to 0 and x is equal to a when an infinite force prevents it from escaping. So the particle inside the well is free to move but it cannot escape from the well because there is an infinite force which prevents the particle to move outside the well. Suppose potential function v of x. When particle lies between 0 and a, the potential energy is 0. If the particle is outside the well, then the potential energy is infinite. So outside the well, the wave function xi of x is equal to 0, which means the probability of finding the particle outside the well is infinite. Consider time-independent Schrodinger wave equation. We know that time-independent Schrodinger wave equation is minus h bar square divided by 2m d square xi by dx square is equal to e into xi. Now rearrangement. D square xi by dx square is equal to e into 2m divided by h bar square into xi. So bring this d square xi by dx square to the right hand side. So d square xi by dx square plus 2me divided by h bar square into xi. We know that E is equal to p square divided by 2m and momentum p is equal to h cross k. Therefore, p square is equal to 2me. Replace p by h cross k. Therefore, h cross k whole square is equal to 2me. K square is equal to 2me divided by h cross square. Now, replace this term by k square. Therefore, d square xi by dx square plus k square into xi is equal to 0. The general solution is xi of x is equal to a sin kx plus b cos kx, where a and b are constants. So now apply the boundary condition. So xi of x at x is equal to 0. So we have xi of x is equal to a sin kx plus b cos kx. Therefore a sin 0 plus b cos 0. We know that sin 0 is 0. Therefore this term vanish and b cos 0. Cos 0 which is 1. Therefore b is equal to 0. Therefore xi of x, the wave function is a sin kx. Now again apply the boundary condition at x is equal to a. Therefore a sin kx is equal to 0. Since a is not equal to 0, sin kx is equal to 0. Because we know that sin theta is equal to 0 when theta is equal to integer multiple of pi. Therefore k into x is equal to n into pi, where n is equal to 0, 1, 2 and so on. Rearrange this. K is equal to n pi by a. So now k into a is equal to n pi. So squaring on both sides, k square into a square is equal to n square into pi square. Replace k square by 2me divided by h cross square into a square is equal to n square pi square. Now we want energy. Therefore energy is equal to n square pi square into h cross square divided by 2m into a square. This is discrete energy levels. The boundary condition at x is equal to a does not determine the value of a. We does not get the value of a. Therefore, to find a, we normalize the wave function. Therefore, Xi is equal to integration from 0 to a mod a square sine square kx into dx is equal to 1. We know that the integration over 0 to a mod xi of x square into dx is equal to 1. Replace mod xi of x is mod a square sine square kx into dx is equal to 1. So a square is constant, therefore bring this outside. Mod a square 0 to a sine square kx into dx is equal to 1. We know that trigonometric equation cos 2 theta is equal to 1 minus 2 sine square theta. Therefore sine square theta is equal to 1 by 2 into 1 minus cos 2 theta. Replace sine square theta by 1 minus cos 2 theta divided by 2. Therefore mod a square integration 0 to a 1 by 2 into 1 minus cos 2 kx into dx. Here theta is k into x. Therefore 1 by 2 mod a square integration from 0 to a into dx minus integration 0 to a into cos 2 kx into dx is equal to 1. So we know that the integration of dx is x. Therefore by applying the boundary condition we get a. Right? Now we must integrate cos 2 kx into dx. To integrate cos 2 kx into dx, assume that u is equal to 2 into theta and du is equal to 2 into d theta. So integration cos 2 theta into d theta is equal to 1 over 2 integration cos u into du. So now integration cos 2 theta d theta is equal to 1 over 2. We know that integration of cos x will be sin x. Therefore sin u plus c. Therefore 1 by 2 sin u means 2 theta. So 2 theta plus c. We get 1 by 2 sin 2 kx plus c. Now replace cos 2 theta into d theta by 1 by 2 sin 2 kx plus c. So 1 by 2 mod a square into a minus 1 by 2 sin 2 kx integrate within the limit 0 to a is equal to 1. So 1 by 2 mod a square as it is a minus 1 by 2 sin 2 into k. We know that k is n pi by a into x within the limit 0 to a. We know that the value of n pi means sin 180 is 0, sin 360 is 0. Therefore this term 0. Therefore 1 by 2 mod a square into a is equal to 1. So mod a square is equal to 2 divided by a. So a is equal to root 2 by a. Finally we get the value of a. Therefore inside the well the solution are xi n of x is equal to root 2 by a into sin n pi by a into x. Thank you.